Welcome you all. I am Professor Yogesh Kokate from Mechanical Department in the subject System in Mechanical Engineering. Today we are going to learn the thermal engineering. Before going to the thermal engineering, we have to understand the basic concept of thermodynamics. So what is meant by the thermodynamics? So thermodynamics is the science deals with the concern with ways energy is stored within the body and how energy transformation take place, which involves heat and work. So heat and work, this kind of energy, how it is get stored inside the body and how this energy will be get transformed, that science is known as an thermodynamic. So it is having two approach, that is microscopic approach and second microscopic approach. In macroscopic approach, study is based on large number of particles, and here we are not taking the single individual particle behavior. In microscopic level, the effect of heat and work or the energies we are consider each and every particle. So at that time that behavior is we called as an microscopic approach. Now why we want to learn the thermodynamics? So as we know that thermodynamics is a science which concern about the energy store and energy transformation. So there are different application of it. So let's see what are the different application of thermodynamics. So if you see over here, air conditioner, car radiator, power plant, these are industrial application where we need the knowledge of thermodynamics. Aeroplane, aerospace are nothing but again over there thermodynamics knowledge is required. Refrigerator or air conditioner are domestic appliances where again thermodynamic knowledge is required, or where we apply our thermodynamic knowledge. Again, for different mechanism in human body, to understand it we required knowledge of thermodynamics. So in all these field we required a thermodynamic knowledge. That's why these are application of thermodynamics. So what are the different types of thermodynamic systems and what is meant by system before that? So system is nothing but the one region in a space where we have to focus to take its observation. So it is quantity of matter or a region of space chosen for study. So for example, right now we are focusing on this PPT. So this presentation is a system for us. That means for that moment, whatever we focus or whatever region where we are taking the observation are nothing but the system for us, and rest of the things outside that one is nothing but the surrounding. So surrounding is nothing but the physical space outside the system boundary. So what is meant by boundary? Boundary is nothing but the one imaginary or real layers that separate system from its surrounding. So very simple, for a space we chosen for study is nothing but the system, and anything outside that space is nothing but the surrounding. The system and surrounding are separated by the boundary. Now what are the different types of system? Closed system, open system and isolated system. Let's see one by one. First, closed system. So the system in which only energy can exchange, that can enter inside the system and that can coming out from the system, but not the mass, then that type of system is called as an closed system. For example, pressure cooker. So inside the pressure cooker, if I put something, it will not come out. Consider ideal case, pressure cooker vessel is an off mode. There is no steam is coming out from the pressure cooker, and if I giving the heat from bottom, then only energy can exchange, not matter or not mass is get changed or exchange. So it is an example of closed system. Another closed system which having moving boundary. For example, here if I heat it up, only energy transfer, along with that boundary will be get changed. So in previous case boundary are fixed, in this case boundary are moving. So these are two or these are the types of closed system. Next, open system. So in an open system both mass and energy can transfer. So we can take an example of a turbine in a power plant where the steam can enters, that means mass is enter. Second, this mass having the energy that will be delivered so as to work done will be happen. So both mass and energy can transfer. So it is an example of open system. Next, isolated system. In isolated system both mass and energy is not get transfer. So or heat or work is not get transfer across the boundary. For example, ideal thermos. So in a thermos we put it anything, it will be remain for the or its temperature and whatever may be the property will be remain as it. So not a mass and not a energy will be get transfer outside the thermos. But after some time its temperature will be get decreases, that means energy will be get exchange. So at that time it will not a example of isolated system. That's why I said it is an ideal thermos. Or if I want to give another example, then typical collection of many systems and in one surrounding is nothing but or different surrounding is nothing but the one kind of isolated system. So here you can see that this is the system and which can exchange the heat in between the different surrounding. So here nothing is coming out from this whole system and surrounding outside, and nothing is coming inside in between this system and surrounding. So there will be no exchange of energy and the mass. So this is again a typical example of isolated system. Now properties. So what is meant by property of a system? It is an characteristic of a system in equilibrium is called property. In very simple language, we ask about the person. When we ask about a person, we ask like this, how he behave, what is the nature of that person. Like this we ask. That means we are asking the characteristic of person so as to we can imagine that person. So like that, for the imagination or to get some idea about the system, we define the property of a system. Then what are the types of properties? So there are two types of property. One is an extensive property and second one is nothing but the intensive property. In extensive property, it is vary as per the size or as per the mass, like volume, mass. These are dependent on volume, and let's say volume is dependent on size. That means if I take an example of oil, there is, when we put the oil, or if I want to measure the oil in the volume, at that time it is totally depends upon size. If the properties are not dependent on the size, then it is an intensive property. For example, for a room, if I want to take the temperature of room at the center, or if I take the temperature of the room at one corner, at both the locality temperature are same, so it is not depends upon the size, so it is an intensive property. All extensive properties per unit mass are nothing but the intensive property. So like specific volume, density are nothing but your extensive property. So density, for example, if I am taking a single molecule of water, or if I am taking a sea of water, all having a same density, that's why it is not depend on size, so it is an extensive property. So next one is nothing but the state and equilibrium. So state is nothing but if one property changes, then the state of the system will be changed. So the state is nothing but a one kind of situation of the system. What condition possessed by that system is nothing but the state of the system. So what are the different types of equilibrium, and what is meant by equilibrium? Equilibrium is nothing but the balance of state. So what are the different types of equilibrium are there? First is thermal equilibrium, where temperature of the system remains uniform. So if I say two system having thermal equilibrium, so means that two system having thermal equilibrium. Mechanical equilibrium means there is no, or there is an forces on the body but they are equally distributed on a body, or there is no forces on a body. In both the cases we say that it is in mechanical equilibrium. Phase equilibrium, that means phases are same. Chemical equilibrium, so that means there is no any kind of chemical reaction in the system. These are nothing but the equilibrium of the system. Thank you.